So today, for our last presentation, we have Professor Shakhashiri with us.
Good morning, everyone, and welcome to UW-Madison. I am very pleased to be part of the faculty, inviting you to participate in a very meaningful educational experience. My presentation this morning is a bit different from what you've been hearing so far. I'd like to share with you and highlight some aspects of your life in graduate school and beyond. And I want to speak about opportunities and challenges. Usually people talk about challenges and opportunities, but I think opportunities are very important. So I invite you to visit my website, scifund.org. But I also want to call your attention to the fact that we are very much engaged in research and public engagement activities. Next slide, please, Taylor. You recognize our mascot, Bucky Badger. If you look closely at this photograph, you will see Bucky obeying the safety rules. He's wearing goggles. Eye protection is very important. Safety is paramount in everything that we do in the lab and outside the lab. Bucky is doing an experiment that involves lead, the formation of lead iodide. He's mixing a solution of potassium iodide with lead nitrate. Actually, the way Bucky is doing the experiment is not the safest way to do it, because if you add the lead nitrate to the potassium iodide, then you get less usage of the metallic lead nitrate solution, which would be safer to do. You notice the label on the bottle. He's adding the iodide to the lead nitrate. That's a beautiful reaction. You take two clear and colorless liquids, you mix them together and get this beautiful yellow insoluble substance that we call precipitate. Now, as I said, safety is paramount in everything that we do. And the full screen, Taylor, full screen, because I want to emphasize the importance of wearing masks. Everyone should be wearing a mask now. And if you see someone in your immediate vicinity who's not wearing one, you emphasize to them the importance of wearing it, and make sure that the clip is on the top and it is held to your nose tightly. If you wear glasses, as I do, and your glasses fog up, that means it's not very tight. Any reliable mask would be helpful, whether it is one made by a friend, as this one is made. I don't know if you can see what it says on it. It says "Science is fun" on it. This is also one with the clip that's on top. So safety is paramount in everything that we do. And I'd like to also call your attention to a report that the American Chemical Society put together 8 years ago when I was the president of the ACS. This report is about graduate education in the chemical sciences. You will find a link to it on my website. I urge you to look at it because it has recommendations related to your aspirations as graduate students and also to helping science meet societal needs. Next slide, please, Taylor. I call your attention to the Wisconsin idea. I do not have the ability now to ask for a show of hands to see how many of you know what the Wisconsin idea is, but I ask you to find out what it is, because everyone who attends UW-Madison should learn what the Wisconsin idea is and should learn about its profound impact, not only on the state of Wisconsin, but on the nation, and it is actually applicable around the world. Briefly, the Wisconsin idea is over 100 years old now, and it says that the boundaries of the university are the boundaries of the state, the boundaries of the nation. And as I said already, it goes all the way around the globe. I would urge you to, in the strongest possible way, to find out what the Wisconsin idea is, because you are going to become part of it. And again, if you go to my website, you'll find links that relate to the Wisconsin idea and give you more information about it. Next slide, please. I share with you here the grand challenges to society and to scientists. The question is, how can we help sustain Earth and its people in the face of population growth? I ask you as a time marker to think back to what you were doing 4.5 days ago. Just use that as a time marker. Don't tell me what you were doing. Don't tell anyone else. Just think about that as a time marker. Because in the past 4.5 days, the population of the world has increased by 1 million people. The net increase in the population around the globe is 1 million people. If you do the arithmetic on an annual basis, that is approximately 80 million people. 80 million people is the approximate population of Germany. It's also the approximate population of Egypt. Two very different countries. I submit to you that everything we do in our research can help address these questions, these challenges that I'm sharing with you right now. So the next one I have, next bullet, is finite resources. Full screen, please. Full screen. Around the world right now, there are 1.3 billion people who cannot do what I'm about to do. Take a sip of clean water. How can we, back to the slide, please. How can we, as enlightened individuals and responsible people in our society, tolerate the fact that this finite resource is not available to others around the globe? It is crucial for us to use our science and technology to advance the human condition. The third bullet, which is one of the grand challenges to society and to scientists, is malnutrition. And obesity is part of malnutrition. The next bullet is spreading disease. Do I need to say more about that now? The next bullet is deadly violence. Do I need to say more about that now? The next bullet is war, a grand challenge to society and to scientists. The next bullet is climate change, and I'll say a few more words about climate change very shortly. But I call your attention to the very last bullet at the bottom of the slide that reads, the denial of basic human rights, especially the right to benefit from scientific and technological progress. We advance science, we advance technology to help advance the human condition. Yet around the globe, in our own country and in other countries, basic human rights are denied. And you and I should commit ourselves to make advances in science and technology available to everyone. This is a basic human right. Usually we think of human rights as being political, which they are. But I submit to you, for those of us in science, that one of the most important basic rights is to share the benefits of scientific and technological progress. Next slide, please. This is a depiction of the state of Wisconsin, and it shows the plant hardiness zones in 1990 and in 2012. You can be in second grade or third grade, and you can see that the color codes tell you that there is a change in the hardiness zones. This is one of the important telltales of global warming. Climate change is upon us, and it is, as I said already, one of the grand challenges that we face, and we must be doing the right things about it. You notice in a short period of time that the temperature is going up. A question for you to think about: how does one measure the temperature of the Earth? Do we take a thermometer and stick it in the ground and measure it? That's a scientific question, but we think about the science that we do, how we make measurements, how we interpret the measurements, how then we share that information with others in society who are not scientists. Next slide, please. This is a graph showing the duration of ice on the surface of Lake Mendota. Welcome to Madison. Welcome to a very beautiful setting. This graph shows the duration of ice on the surface of the lake over a long period of time. You can see that there are fluctuations on an annual basis, but the trend is very clear. The slope is negative. Next slide, please. This is another way of showing the same information. Ice off, ice on. Again, the fluctuations indicate differences on an annual basis when the measurements are made. And it is important for us to recognize that the duration of ice on the surface of Lake Mendota and other bodies of water are telltales of global warming. Global warming is real. Next slide, please. This is a display of the amounts of carbon dioxide in the atmosphere as measured on the top of Mauna Loa Observatory in Hawaii. This is the well-known Keeling curve, named after the scientist Keeling, who started making these measurements, as you see at the bottom of the slide here, way back. And you notice here that the variations are symmetrical. That tells us something. What is the something that tells us? I want you to think about that. But you also notice the most striking thing about this graph is that the amounts of carbon dioxide are increasing in the atmosphere. And carbon dioxide gas is a greenhouse gas. Greenhouse gases are helpful to us because if it weren't for greenhouse gases, the temperature on the surface of the planet would be as cold as it is on Mars. But too much of greenhouse gases is not good for us. Well, you might say, well, 412 parts per million, that's not a lot of carbon dioxide. Parts per million, that's a small amount of measurements. But on the next slide, I show you what that translates to. What that means, 1 part per million is equal to 8 gigatons of carbon dioxide. 1 part per million, 8 gigatons. Now, if you take the approximate population of the planet to be about 8 billion people, we're not quite there, but let's approximate that it is 8 billion. That means each one of us is responsible for producing 1 ton. You and I know that those of us who live in the industrialized world produce much more than others on the planet. And that's why you and I, as scientists, have an awesome responsibility, not only to generate knowledge, not only to understand the beautiful complexity of the world that we live in, but to use that science and that technology to serve society. Next slide, please. Global warming is unequivocal. Global warming is unequivocal. That's an assertion I make to you and to others. But if we're having a conversation with someone who's not in science, if you start out with this statement, you have a high likelihood of turning people off and not being able to continue the conversation with you. So you have to be selective, as I am selective, about the words that we use to successfully and effectively communicate science to the general public. And that's why I urge you, all of you, full screen, please, full screen. I urge you to vote and to get 5 other people who have not voted before to vote, for 5 other eligible people to vote. It's important that we exercise our rights and express ourselves, and we must vote in every election. Please register to vote. Please vote in person safely or preferably by mail. Please do that. It's very, very important that you do that. All right. Now what I'd like to do is an experiment, and this experiment has to do with this glass of water that I have right here. It is water. What I'm going to do is ask you a question. The question is, do you always believe what you see? You always believe what you see? Well, here's the experiment. I take a card that has two arrows on it. You can see they're pointing in the same direction. And then I need to raise this a little bit here. Let me just get a little prop here so you can see it a little bit better. There we go. You can see the level of the water. Maybe even higher would be better. There we go. I take the card. You see the arrows are pointing in the same direction. I hold the card behind the glass and then I lower it. Whoops. What happened? Arrows are pointing in the same direction. I lowered the card below the surface of the water. What happened to the bottom arrow? Think about that. This is an experiment that has to do with illusions. Think about illusions. Think about optical illusions. Think about visual illusions. Think about the rainbow. Is the rainbow real? Of course the rainbow is out there. Is it an illusion? Is it an optical illusion? Is it a visual illusion? Always think about what observations are being made and how we can interpret them so that we can learn more about our perception of the beautiful, complex world that we live in. Next slide, please. You're beginning your graduate work now, and I hope in 4 to 5 years, aim for 4, you finish your PhD. My research and public engagement group called the Wisconsin Initiative for Science Literacy promotes communicating chemistry to non-science audiences. We invite all graduate students to include a chapter in their thesis explaining their research to non-science audiences, explaining your scholarly work that you've labored for 4, 5, sometimes longer years to a wider audience that includes family members, friends, civic organizations, newspaper reporters, elected officials, and we provide a cash award of $250 to every individual who does that, who does include a chapter in their thesis explaining the research to non-science audiences. And we have an editor that can help you once you prepare your first draft. So this is something for you to think about for the future. It is an opportunity that is available to you being enrolled at UW-Madison. Next slide, please. We are engaged first name, Bassam. Why do you do science experiments? Next slide, please. Why do you share science with the public at large? I ask you to look at the faces in this photograph that was taken at a shopping mall in Madison. Look at every face, youngsters, adolescents, adults, grandparents. Look at their facial expression. This is why we care about engaging the public in our science. This is why we want to promote science literacy. That's what my research and public engagement program is about, engaging others, promoting and achieving science literacy. Now, under the present pandemic situation, we cannot do that in person. But whatever we do via the internet, I am hopeful that we can generate the same facial reactions as you see in this beautiful picture that was taken at the Hilldale Shopping Mall several years ago. Now I come close to the end of my remarks here, and I ask for the next slide, please. Here's a partial list of the challenges that I think you are facing, and I ask you to address them successfully. Next slide, please. Get enough sleep. Pay attention to your personal well-being. Next slide, please. Enjoy nutritious food and beverages. Yes, beverages of all varieties. And be responsible in using alcoholic beverages. When you go to my website, scifund.org, you will find an entry called Learn About. Under the Learn About entry, there are many useful information and guidance about ethanol, about ethyl alcohol, and so many other chemicals. So my next slide shows you the third challenge. Do physical exercise. Stay healthy. Next slide, please. Pay close attention to your mental and emotional health. You are responsible for your physical, mental, and emotional well-being. Pay attention to that and lead a healthy life. Next slide, please. Also monitor your professional progress. There's something called Individual Development Plan that's available through the chemistry department, also from the UW Graduate School. This is something that I urge you to start doing right away. Develop a plan, work with your advisor, work with the other guidance people that we have in the department and on campus to develop a meaningful, realistic, professional progress plan so that you can really succeed and enjoy being a graduate student in Madison. Next slide, please. And I ask you to live the Wisconsin idea. That means you have to find out what it is first. So you go to my website and you can find out what the Wisconsin idea is and how you can live it. Next slide, please. And do good in the world. Make sure all your deeds are for the benefit of others as well as yourself. Next slide, please. And have fun. Fun in the real sense of the word. I'm not talking about cheap thrills here. I'm talking about having fun, becoming intellectually stimulated, emotionally rewarded. That's the kind of fun that I'm talking about. Next slide, please. Now, normally I do this presentation in person. I do lots of other experiments, but I can't do it today because of the settings that we're in. So I invite you all to go to my website and look under the YouTube channel that we have, and then click on the presentation I made last year to the incoming graduate students. And you will find that I have a similar message to what I've shared with you so far. But you'll also see the experiments live, and you can hear the audience reacting. So, and you don't have to copy down the URL here. Just go to scifund.org and then look in the colored cylinders, and you'll see an entry that says YouTube channel. And browse around a little bit. You'll find the 2019 video from last year. Enjoy watching that. Next slide, please. And if you'd like to connect with me, please, as I said already, visit the website. At the bottom of the website, you will find an email address. You can communicate with me directly that way, or you can look up my direct email address in the departmental directory. Once again, I welcome you to the graduate program at UW-Madison. I wish you all well. You have a unique experience unparalleled in history because you're joining us under a very serious and severe set of conditions. But I am hopeful that you will succeed in what you want to do, and you should be assured that we are here to be of support and to provide guidance and to have you succeed in becoming a scientist. About halfway through your graduate career, there'll be a big transformation. You transform from being a student to a scientist. So best wishes to all. If you have any questions or comments, please connect with me electronically, either through the website or to my direct email, which you can find in the departmental directory. Thank you.